So for the y values though, y's are easy. No problems with y's. What you see is what you get. Okay, so for the y's, because we're on this side, we're going the right way through the function. Okay, to get my new y's, we're going the right way. If it says plus, we go up. If it says minus, we go down. Okay, so in this case here, since it's on the outside, it's a y. We're going the right way through the flow chart. So y's are easy. What you see is what you get. So here's an example here where we start with a root function. It's going to be absolute value of x. So our root function, we need to choose some reference points. One reference point for the absolute value functions is you have to use that vertex. Okay, that's a key point. Okay, the other points are kind of arbitrary. I'm going to just go maybe minus 2 and 2, 2 and 2, minus 4 and 4, 4 and 4. Okay, so but that vertex is important. Okay, you need to be, for an absolute value function, you need to show the vertex. So here's my absolute value function. And it's important to note again that once I've established the function, I don't use that absolute value to calculate new coordinates. Okay, I'm going to use my transformations to calculate the new coordinates. So my transformations are inside is x minus 3. That's my x transformation. So it's going to look like this in function notation when I plug it in. On the outside is minus 4. So that's my y transformation in function notation. When I apply it to the function, it goes on the outside as minus 4. So this is secondary, using the function notation to put into the actual equation. What we're really looking at is how do we transform the x, how do you transform the y, and making sure that we're doing it separately. Okay, so we kind of have an idea what this looks like. So we graphed these before. The vertex should be at 3, negative 4. So let's make sure that when we do this transformation that we end up with that. So I'm going to start with the y's, okay, the change in y. And then I do y's first because y's are easy. Okay, take my original y's and I'm going to apply my function notation. In this case here, it's minus 4. So I'm going to apply my function notation. And then I'm going to take that, all the y coordinates, and use this transformation to get the new y coordinates. So here I get 0, negative 2, negative 4, negative 2, 0. And again, I did my y's separately from my x's because they have nothing to do with each other. Okay, they're on the opposite sides of that transformation, the function flowchart. So then now I'm going to move over to the x's. So my x, my change in x. Okay, well, this is my notation. Okay, so this is what I see in my notation, but my notation is backwards of what I want to do. So because it's backwards, I'm going to undo this expression. So I'm going to solve for the other x to get my transformation equation. And so I wrote here n for notation. This is what I see. And I'm going to put d here for what I do. Okay, this is what I actually do. This is what I see in the notation. This is what I actually do. I'm actually going to plus 3. So I'm going to take all these x's and apply this transformation. And I get my new x's. So I get negative 1, positive 1, positive 3. That's going to be positive 5, positive 7. Okay, so this is the x's are, we have to be careful because they're done backwards. And to show the backwards, I just undo this notation calculation by solving for the other x. Okay, and this gives me that calculation from the old x to the new x. So when I plug in these coordinates in, I get negative 1, 0. Okay, I get 1 over negative 2 down. I get 3 over negative 4 down. Okay, there's my vertex. 5 over negative 2 down. 7, 0. There's my transformed equation. It is the same equation that's been moved 3 to the right, 4 down. Okay, that's just what we expected. Okay, so again, it's important to understand that x's are backwards, y's have no change. So y's are really easy. X's are backwards. To help us with the harder backwards one, we're going to undo. So we have this notation of what we see, and we're going to undo it to actually do the actual physical transformation.